It says for each of the RPC services we found, put those into a pretty table to show the user. We do a table.sort on the results so that they're sorted. And then we do standard NSE.format output to, again, that just makes the output prettier and more consistent with how Nmap scripts normally do it. And we pass it this string of RPC results that we've generated. So it's actually, as you can see, quite a simple script, but does a pretty useful function for your scanning. So that's one script. And now I want to look at one which is a little bit more complex, but not dramatically so. Let's take a look at that script that had us so much fun, the SMB enum users. Oops. So this one we can see is 262 lines. So it's about 5 times as long as the RPC info. So let's take a look at what it has. So we start with the description again. And Ron is a very verbose person. He actually does great comprehensive and complete documentation, which is really wonderful when you're trying to figure out how a script is working. And so we go on through the description and the usage information and the output information. I was thinking of changing the output to the Microsoft stuff for the default page, but the argument documentation for the arguments that it takes. And so here it's really starting the code, and we're to line 141 of 262. So more than half of this script is documentation. So now let's get to the meat of it. Now, the last script was what we call a port rule script. And so it runs against a certain port that was found open. If there were three RPC bind ports open for some reason on the machine, it would have gathered the information for all of them. This SMB script is called a host script because it runs once per machine. And so it has what's called a host rule, which tells Nmap which hosts to run against. And in this case, it's pretty simple. It uses an SMB helper function that says get any SMB or MSRPC port from the target machine if there is one. And we check if it's not equal to nil. So if we actually got a port from the machine, if it's got no SMB ports, it would have returned nil, and Nmap would have skipped the script for that host. But if it does have an SMB port, Nmap runs the action function again. Here we have a lot of variables. And you can kind of see that even if you don't know Lua specifically, this is the same sort of stuff you do in any scripting language, and so you can recognize the variable declarations, the operators. Here we first try and gather the usernames through SAMR, which is a little bit, it's the most effective of the means of gathering the usernames from an MSRPC server. And then we also try doing it through LSA, which is not quite as effective, but sometimes you can't get them through SAMR. We take these results and then we format them again. We're kind of limited on time, so I'm not showing like each line, but we format them, we sort them. Ron did a smart thing in that he breaks them up by domain. So if a domain controller, there could be several domains and you can get them listed by each. We check. This is all more formatting, all those different extra information we got, like the people's full names and nicknames and password details. It's doing all that. If you're in verbose mode, it's still creating the response. And then finally, we get this final line again, which says, Nmap, here's the string we formatted with all the results. Please present this to the user for that host. So now we've seen 2 examples of NSE scripts in basically how they're coded. And we could go on and on with that, but what actually seems like it would be more fun is to do a demonstration. David is actually one of the best script developers on the planet, and he's going to show us how you can actually write a script on the fly, from scratch, with hundreds of people staring at you for any mistakes you might make, and he's going to do it right now.
Thank you very much. All right, so let's prove how easy it is to write an NSE script. This is something that I think any programmer can do. Let's demonstrate this kind of on a toy example. Before I left home, I set up a webcam aiming out at the beautiful city of Denver, and I want to try and see that webcam picture. The problem is, it's on my standard home internet connection, and it's on a dynamic IP address, and I don't know exactly what the IP address is. So let's write a script to find it. Before I left, I found out a couple of attributes of this webcam that'll help us fingerprint it. It serves a file called cam.jpg. The server is HTTPD, and I found that that's enough to reliably find this webcam. So we're just going to open up a file. The customary file extension is .nse for scripts. Script has to have a description. Categories for this script. It's a pretty safe script because we're not doing anything weird with HTTP, and I would also put it in the discovery category. Port rule, this is what decides if the script is going to run. Here we just want it to run for HTTP ports, so this is going to be a simple rule. Return port.number equals 80. See, Lua is easy. Now the action function, this is where things really happen. Now since we're going to be using the HTTP functions, I have to go back and we're going to require the HTTP library. A local variable here for the HTTP response. Response equals http.get host port. We want to retrieve the file cam.jpg. And now we want to test if this actually works. So we're going to say if response.status and response.status is not equal to 404, right? Because that's no good for us. This is how you say not equal to in Lua. And response.header, we can query the header values, so we're going to look for the server value here. First we're going to check that it exists, and then we're going to check its value. String.match is a standard Lua function. And we're going to match it against the pattern THTPD. Then it's real easy to return results from an NSE script. You just return a string. Oops. And so this is it. In case we don't find it, we just return nothing, and that's going to make the script remain silent. So let's give this a try. I'm going to run an Nmap. I'm going to run this script, and I'm going to add a couple of options that make this scan faster. So pay attention here. You might learn some tricks in case you have trouble with the speed of your Nmap scans. We're going to turn off reverse name resolution, turn off ping scanning. We only want to scan port 80. I only want to see hosts that have an open port. We want to run the script HTTP webcam. The ISP's address space is what I want to search here. Let's log the results to a file just in case it scrolls off the screen. And finally, this is a good tip. Always add the debugging flag when you're testing your NSE scripts, because that way when you have a syntax error or something, you'll get a backtrace. As if. I mean, we're just testing this out for the very first time in front of a room full of people. What could possibly go wrong? Give this a try. Okay, so Nmap is fast. Let's open up the results file. Webcam found. Excellent. So we found it at 66.7.171.5. And that's all there is to it. Oh, you want to actually see the webcam? All right. Yeah, sorry. I did check to make sure this would work, but... Huh. Okay, so we have a little problem here, but let's not be daunted. to an Nmap developer, there's always a solution. The solution usually involves doing more scanning. So let's do this. Here's the game plan. Are you with me? So let's start again with the description. Guesses HTTP passwords. All right, so we can't really justifiably put this in safe anymore. I want to require, again, we're going to need the HTTP library. We're also going to bring in our username password database library, because that's going to do the hard work of password guessing for us. Port rule is going to be exactly the same. Action is going to be a little bit different. We need some local variables here. We need a usernames iterator, a passwords iterator. We're going to need an additional status variable. Okay, so obviously, I know what this is going to look like, but if you don't know how to write these iterators or how to use them, this is all in the online NSE documentation. This is all outlined for you. So now this is simple. We're just going to write a nested loop here for password in passwords do, for username in usernames do. Again, we want a local variable for the response. Okay, we want to retrieve cam.jpg, and now I'm going to pass an additional parameter here with some extra options. I want to pass our authentication information here. All right, so what are we looking for here now? If response.status and response.status is not 401, because 401 means authentication required, then return username, ... is string concatenation, and we're going to end the username loop, something you have to remember to do. This is the only really tricky part of this script. You have to remember to reset that username iterator. And finish off the action function. So let's give this a try. I'm going to run a very similar command. We don't need to log to a file because this won't produce that much output. We found out the last octet was 5. This doesn't matter much for here. Oh, and remember to change the name of the script. We want to run the brute script. And go. Those of you who have done this before know that password cracking tends to take a long time. So to help pass the time, let's instead look at some of the documentation for this username password database. And kind of explain what's going on here. So if we go to look at the documentation for this library, we get a description here. You see this little trick of using reset to reset the iterator. It tells you about the default timeouts. These iterators don't run forever. By default, there's a time limit. So these scripts will eventually end even if they can't guess the password. It depends on the Nmap timing level. It tells the format of the data files if you have your own username or password lists. It tells you the script arguments so you can control how these iterators work. So for example, UserDB, if you have your own username database, you can control how many names are guessed. Password database. And here's exactly what I referred to. This should look very familiar because this is basically what I just wrote in the HTTP brute script. The doubly nested loop, resetting the iterator. I mean, this is the documentation I referred to when I was preparing to write this script. And then a list of the functions that come along with it. You saw that we used the passwords function and the usernames function. And there are a few other that you can get access to if you want. So let's check on this. Oh, it finished in 60 seconds. And oh yeah, butterfly. That's the password I use for all my accounts. I should have known.